Okay, so this is a picture that I've made up of what it might look like behind the scenes. So we start with three ideas of whether something's cat-like or dog-like, and these are just simple ideas. And then we mix them together in some way. Like maybe this one is, if this is 1, 2, and 3, maybe this is 3 times 1. I don't mean the number 1, it's 3 times this one. Cats are fighting. Plus 2 times 2 minus 4 times 3, for example.
Yeah.
Okay, and then, so they get mixed up, and then these mixed up ones get mixed up, and then they output here, and maybe they're good at telling the difference between cats and dogs.
And then if they're wrong, would you like remove the thing that got you to the wrong assumption, sort of like we did with the matchbox thing?
No, that's actually a great question. That's the whole. That's kind of the whole point about how machine learning works. Like, what do you do? How do you move forward if you're wrong? And instead, you're right. One idea is you might just delete something entirely, but that would be, say, like this one here. Maybe I just delete the 4. I just delete this line. Mm-hmm. Instead of deleting it, which would be the equivalent of changing the weight on that to 0, then you find out how to adjust the weights. Maybe the 4 becomes a 3.5 or minus 3.5 or something. So it's actually not super hard, but that's what the next step is. You look at your data, and you take bits of it where you actually do know the answer. I know these are cats, I know these are dogs, and you see how good your program was at checking them out, and then you find ways to improve it. But you could proceed a little bit randomly in the beginning if you wanted to. You could just run it like a couple thousand times and see which ones were the good ones and which ones were the bad ones, and sort of see if you were moving in a direction. Now that direction would be in very high dimensional space because we got lots of variables here.
Yeah.
But you, instead of removing them, which is setting the weights to 0, you adjust the weights and see if you get better. But there's one other really interesting thing that they do here, which is actually the reason I wanted to talk about it, because it turns out something kind of surprising happens, or happened in this setting. They found, when they were designing these machine learning algorithms, or sometimes they're called neural networks, that, so you think of these as being neurons, and the neurons fire a message. Okay? So they found that when a neuron had, its total, let's call it the weight, let's say the weight was either, it could be 5, or the weight maybe was, minus 2, or the weight was, 10, or what, something like that. They found that the machine learned the best not when you just passed the weight through to the next round. So in other words, the neuron just always fired with whatever weight it had. Mm-hmm. They found the machine learned the best when, if the weight was negative, it didn't fire at all. And if the weight was positive, it fired. So instead of having this y equals x line, in other words, always firing, just pass whatever information you have through to the next level, you had this kind of, if it's negative, don't fire, do nothing. And if it's positive, fire. So instead of having a linear algorithm,
it sort of changes it a little.
Yeah, it alters it a little. It's this very simple, totally simple, non-linear function that causes the neurons to fire. If the weight's negative, don't fire. If the weight's positive, fire. And when they did this with the neurons,
it learned better then.
It learned better, yeah. It's a really simple change. Instead of one line, it's sort of like half one line, half another line. Yeah. So we're gonna take a look at this now, this program on. Actually, you know what? Before that, we're gonna do one more talk before we get to the computer program. Okay.
All right.